So far, we have discussed the electrical symbols and connectivity of control devices and put them to work in ladder diagrams. Those diagrams showed us a way of determining and referencing very quickly how a particular control circuit will operate. We mentioned also that another way to represent parts of the operation was using wiring diagrams. Wiring diagrams, unlike ladder diagrams, are intended to show the actual connection and placement or location of components as close as possible, including the power circuits. Wiring diagrams are extremely useful to electricians and technicians while troubleshooting or designing a control system, since they provide you with a roadmap of the actual wiring. This is not more true than in motor control circuits, which, of course, use magnetic starters and other control devices. As we mentioned, the wiring diagram illustrates as close as possible the location of the wiring connections. In this starter, for example, you will find a wiring diagram like this, which shows all the connections to the starter, in addition to the location of the components within the starter. The symbols in the wiring diagram show the location of these components in the same manner where you would find them if you were looking at the starter from top to bottom. From the top, you have the three terminals that connect to L1, L2, and L3. Immediately below the power terminals, you will find another three terminals shown in smaller circles. These terminals represent and are used for the wiring connections of control circuits, which will be represented in thinner lines as opposed to heavy lines for the power circuits. We'll see these connections in a second. Right below, we find the actual contacts that will turn the motor load on, and below we have another set of terminals which are normally used when we have reversing circuit connections. These can be considered power connecting terminals as opposed to control circuit terminals. Under this second set of power terminals, we find the starter coil represented in the diagram in the middle cross-section, which is the location where you will find it in the starter. Also shown are the two terminal connections that are used in the wiring of the control circuit. Note the smaller, thinner-lined circles which symbolize the terminal connections for the control circuit. When the coil is energized, the motor load contacts close, which in turn start the motor. On the left of the coil are located the auxiliary contacts, commonly used as interlocking or sealing contacts. The terminals are labeled 2 and 3. Depending on the starter, you may also have another set of auxiliary contacts normally open or normally closed. On the lower left, you'll also find the normally closed overload contacts. Depending on the starter, you may find 3 sets of overload contacts, one for each heater coil. If this is the case, you would connect or wire them in series if they do not come internally connected. Although most overload assemblies provide one set of normally closed contacts for all 3 power line circuits, if there is an overload in any of the 3 lines, the overload contacts will be tripped. At the right of the overload contacts in the diagram are represented the overload heaters, which control the overload contacts. Note that the terminal connectors for the heaters are in bold lines to signify the presence of a power circuit. Finally, below the heaters, you'll find the terminal connections T1, T2, and T3 that would be connected to the motor load. In this case, of course, the connections will be for a 3-phase motor. Most of the time, you will find starters that come with some pre-wired control circuit connections, which are done at the time of manufacturing. These include one side of the starter coil to terminal 3 of the auxiliary contact. This connection will be represented in the wiring diagram like this. Another connection might be from the back side of the coil, so to speak, to the one side of the overloads. This connection will look like this in the wiring diagram. The other side of the overload will be connected to the L2 line in the control circuit, just as it is represented in the ladder diagram.